All right, so this is the last slide in the section, I think it was 13.4 concentration section. Um, so we're going to do a conversion between molality and molarity, which is one of the harder conversions. Okay. So here we're going to have a 0.537 molal solution of sodium hydroxide, which has a density of 1.13 grams per milliliter. And we want to calculate the molar concentration of the solution. Okay, so our goal then is to find molar, so that's moles of sodium hydroxide per liter of solution, SOLN. And we're given a couple of pieces of information. We're given the molal concentration. So we know we have 0.537 moles of NaOH per kilogram of solvent. In this case, that's water. Okay. The other thing that we know is the density. When we're working with density in these cases, density is always the density of the solution. And that's important. It's not the density of the sodium hydroxide. It's the density of the solution. And I like to be to write this out. So it's 1.13 grams of solution per milliliter of solution. And the reason I include the solution there is that it helps me when I'm doing the dimensional analysis to cancel things out correctly, okay? So how do we start? Now we know this, all right? We have this, we have our goal, we have these two pieces of information. What are we going to get from moles per kilogram of water to moles per liter of solution? We can make an assumption. What should we assume? Yeah. The density of the solution is the density of the individual parts. Not quite. We can only keep that together. It has to be the density of the solution. What else? Yeah. Yeah, so let's assume that we have 1 kilogram of water, not the solution. Let's assume we have 1 kilogram of water. Okay, we're going to take what we know, and we're going to assume whatever is in the denominator in a nice number, denominator. Okay, so if we were starting, so here we're going to assume we have 1 kilogram of water, 1 kilogram of solvent. If we were starting from moles per liter of solution, we could assume we have 1 liter of solution. Right? That's going to allow us to calculate the volume of water in 1 kilogram, and then from there we can get mass or moles, excuse me, and go from there. We don't need moles, but we can get the liters then. Okay, so if we assume we have 1 kilogram of water, we can then determine the moles of NaOH in 1 kilogram of water. And essentially we're just saying we have 0.537 moles of NaOH. Because we're saying we have 1 kilogram of water. Okay. So from there, we need to figure out, we have moles of sodium hydroxide. Okay, here's one piece of our goal. Okay. Now we need to know the liters of solution. Right? So denominator in our goal. Okay. So to go to liters of solution, we have another piece of information, and that is the density of the solution. Okay. We can use that to find the mass of the solution. So let's write that out. Use liters of excuse me, not liters. Density. Okay. But we need to know the mass of the solution. Right now, we only know the mass of the solvent. We know our moles of sodium hydroxide in our solution. We know the mass of solvent. We do not know the mass of the solution. Mass of the solution is going to be the mass of the solute plus the mass of the solvent. Okay. Because we have, this is a long problem. Because we have the mass of the, because we have the moles of the solute, we can use the molar mass of sodium hydroxide to determine the mass. Okay, so we can get to that. Because we assumed we have 1 kilogram of solvent, we know the mass of the solvent. Okay. So this is going to be mass solute plus 1 kilogram. This is our assumption. Okay. In our assumption, we have 0.537 moles of the sodium hydroxide, 1 kilogram of solvent. So now let's use the 0.537 moles of sodium hydroxide and the molar mass, which is 40.08. Is that right? 40.0 is good enough. Okay, 40 grams per mole sodium hydroxide. And when we multiply that out, we can get the mass of sodium hydroxide. That is 0.537 moles. And we get 21.48 grams. I'll be sloppy here with my sig figs. Okay. All right. Let's pause here. I'm assuming there's some questions. What questions do we have? Yeah. Mm-hmm. We could do it that way, I think. If we say we have so the question is about density. Can we start with assuming that we have 1.13 grams of solution, and from there calculate the molar concentration? So we would know that if we assume we have 1.13 grams of solution, how would we do that? I'd have to write it out, I think, but you might be able to get there. But you need to figure out moles of sodium hydroxide in that, which might be the tricky part. Other questions? All right, so we have our mass of our solute, we have our mass of our solvent. I have kilograms and grams, so I'm going to take my 1 kilogram and convert that to grams. So that's 1,000 grams. So we have 21.48 grams of sodium hydroxide and 1,000 grams of water. So now if we add those together, we get a mass that is the mass of the solution. And it's at this point that we can use density. Now you see we have grams of solution, right? Grams of solution. We go back up. You'll notice that I wrote grams of solution in the numerator of my density. That's the reason I was so explicit in that. Okay. Because now I can see I can cancel this out to get liters of solution. Okay. So we can find, oops, volume of the solution used density. One 1,021.48 grams of solution. And we'll use our density, we'll divide by the density, 1.13 grams of solution per milliliter of solution. We get 903.96 milliliters of solution, or 0.90396 liters of solution. Because we know we're going to want that in liters because molarity is moles per liter. Okay. So we're going to take that number. We're going to take our moles of the sodium hydroxide. We're essentially going to plug it in to our goal, moles per liter. And we'll have 0.537 moles of NaOH per 0.90396 liters of solution. Check our units there. We end up with 0.594 moles per liter. I think oftentimes the hardest thing to do is get started on these. Okay? Making that assumption, we're assuming that denominator of what we know, that's sort of a big step that can be really tricky to make. Okay, so make sure you take note of that. Okay, so again, we assumed that 1 kilogram of water, and then essentially we just sort of worked our way through to get to our goal units, moles of sodium hydroxide, which then became really straightforward once we made that assumption. And then liters of solution, which was a bit harder, and we had to use the density. Okay. Questions?